This is running vintage software, PyPI's aging codebase. So if that's the talk you want to see, you're in the right place. Otherwise, you're not. Before we get started, I just want to say thank you to the volunteers that organize Pi Gotham, the sponsors that make it possible, and you, the attendees, that also make it possible. And I also want to say thank you for coming and seeing my talk.
Yay!
So a little bit about me. I'm Ernest. I'm a software person living and working from Cleveland, Ohio. Since about 2012, I've been contributing to the Python Software Foundation, primarily via the infrastructure team. I'm an avid taco enthusiast, but most of my free time lately has been spent on a hobby I call being a masochist mechanic. This is my Saab. This is actually my first car ever, the actual one. And I've made every attempt possible to make this car like my regular daily driver when the weather's correct. And I've been servicing, repairing, and trying to improve it since I started driving it in around 2003. Trying to drive a vintage car every day can be a pain. Things will break. Cash will generally be the easiest solution. Experts and parts may not be readily available. And engineering assumptions from the 1960s may not be valid anymore. So is it a lost cause to have this vehicle and try to enjoy it and use it? I really don't think so. In general, it's just time to get to work. Occasionally it'll be something like just pulling things apart and cleaning them up. There's some simple telemetry that needs to be repaired. And once in a while there's a need for more invasive surgery. During a recent-ish now conversation on Twitter about my Saab, friend Hennick saw the need to interject. He posited perhaps my being tied up in vintage Saabs was indicative of why I might be so interested in being tied up with things like the Python package index and the PSF infrastructure. Took some time to carefully consider this, and I've determined that Hennick is not wrong. So the Python package index, if you're not aware, also known as the cheese shop until the early 2010s, is the primary repository for publicly hosting and downloading software in the Python ecosystem. I've been one of PyPI's caretakers since about 2012, and during that time I worked with Donald Stuft, Richard Jones, and a handful of volunteers to improve PyPI's availability and more or less keep the lights on. So, quick history. Predating PyPI, there was a thing called the Vaults of Parnassus. It was a hand-curated page full of links to Python stuff. Users could submit links for inclusion, but that's it. It was just glorious Web 1.0 metadata and hypermedia. If you're interested, there are still mirrors floating around. You can Google and go look through them. The actual vault itself is no longer around. Oh, darn it. There we go. But like most parts of Python's core ecosystem, PyPI is the outcome of a handful of PEPs, or Python enhancement proposals. For more information, you can see PEP 1. Oh, darn it. Okay. So anyway, the key PEPs in PyPI's history anyway are PEP 243, which ended up not being accepted, but led to PEP 301, which ended up being the initial implementation of PyPI. PEP 438, or 438, which introduced explicit hosting modes so that people knew if software was being hosted on PyPI or by a third party. And finally, PEP 470, which finally killed external hosting. So all packages that you find on PyPI are hosted on PyPI. So PyPI today, package index, more than 100,000 unique packages, more than 700,000 total releases, about 190 million requests per day, about 36 terabytes of data per day, and like 3 working tests. There's been incredible growth over the past 4 years. So this is the easiest graph to grab because it's our CDN. And over the past 4 years, we've served 117 billion requests, and that's about 13.6 petabytes of data. So where did this code base come from? The initial commit in version control was November 1st, 2002. First release package took place on November 6th. And this code base, as it was written in this commit, is still around and operating today. This is what I want to call vintage software. It's not necessarily optimized, and it's not what you might expect if you went and did this again today. So Anyway, most of the basic parts of this code base have lived on and been extended or modified to build new features. On top of that, it was like built on a hand-rolled WSGI framework, which nowadays we'd all scoff at, but there was no easy off-the-shelf WSGI framework in 2002. Trying to operate vintage software every day could be a pain. Things will break. The opening slide for this talk is every tweet containing the string PyPI down since 2009. If you see yourself in there, go back and remember when that was, and hopefully you'll feel like the frequency with which you saw that has gone down. I think data is important, so I went and charted all those tweets over time, and we are trending down, and that's always nice. So some things we've done just to make availability, over the years problem. PyPI being down is troublesome for many things. People became dependent upon it for CI and CD. They became dependent on it for deployment, tests, etc. So there have been a number of attempts over the years to resolve this, and one of those was redundancy. So there was initially many mirrors, which were community hosted. Users would offer infrastructure and say, we'll host a mirror. And then the client, in this case pip and easy install, included the ability to specify a mirror. The downside to that is it forces you to explicitly say, I want this mirror. So cache is generally the easiest solution. And I'm willing to say that one of the single biggest impacts on PyPI's availability, period, is Fastly. It offered speed. Instead of having to go to PyPI to get the data, you were going to some pop somewhere. Much more reliable installs, very powerful features for controlling the way that the CDN operates, and I just love Fastly. Also a huge advantage is you no longer need to explicitly specify a mirror. You always just install pypi.python.org. And then in general, there was a turning point not too long after Fastly came around, which was moving from this hand-curated, hand-controlled, manually managed, bespoke infrastructure that was 100% volunteer, including the hosts that PyPI was running on, into the cloud. So that was big. We were able to add additional web nodes, have storage that wasn't on disk. It was redundant, replicated, etc. Experts in context may not be readily available. Many people have come in and out of contributing to the Python infrastructure and to PyPI itself. And so it's always an interesting thing to go from oh, that's where PyPI runs, to how do we deploy this and change it safely. So continuing to get real, we went to full configuration management, high availability storage, high availability databases, multiple web servers, and we were on a hosting provider with a service level agreement. So that started in 2013, and we're still running there right now. And engineering assumptions from 2002 might not be valid anymore. Luckily, most of these things I'm about to talk about have been removed at this point, but they were security or just useless features that sort of landed because PyPI was the primary presence of Python on the web. Python.org is mostly a static site at this time, so you have an active web server, you want to implement a feature, throw it in. Custom WSGI framework is sort of an anti-feature. There was a point where SSH uploads were available to try to work around the fact that we weren't living in this golden era of TLS and HTTPS we live in now. There were fragile and less than truthful real-time download counts that cost. Real-time is expensive. I mean, most people understand that, but the feature lived so long that people became dependent upon it, and it was really hard to take away. There was an OpenID provider, so you could log into other sites with PyPI credentials. There was an OAuth provider, so you could log into sites with your PyPI login. And we were using some out-of-date DSA assigning to attempt to handle some, cryptography, if you will. So is this a lost cause? Should we just throw PyPI away, shut it down, and walk away? A little, yeah, I think so. One of the biggest drawbacks to the current code base is onboarding new contributors. It's the primary reason I'm giving this talk. I want everybody that's in this talk to think about ways that you might get involved with making PyPI better and making the service more robust. But onboarding contributors was difficult. Dependencies, the database schema, custom web framework are 15 years old, and generally cause more problems than they solve. So with that, there's some information I want to talk to you about Warehouse. Warehouse is a full rewrite of the implementation of Python package index. Donald Stuft has been working pretty tirelessly on this for quite some time. And it is extensively 100% test covered. We have documentation around how to get it set up and running and how to operate it locally and work on it. It's built with modern best practices, and it's also specifically built with caching in mind to try to optimize, the cost of running infrastructure on the back end, primarily push that off to the CDN. So it's time to put PyPI on live support. We understand that there will be a time when we turn off this old code base at this point. So the meat of this talk is on some of the methods, which I hope to get through all of them, but given the time constraints, we might only talk about a couple. But these are some of the biggest, top line issues that I have focused on in keeping PyPI up and available and happy as Warehouse comes forward. So some warnings, we're going to talk about concepts, so don't focus on specific implementation or vendors or code or libraries I'm talking about. There will be some code on the screen. Try not to read it all at once. I'm going to highlight lines as we go. And the goals are different than your average production system. So some of the approaches are a little zany because we're doing some things differently. So the single biggest enabler of effective change has been metrics, especially given limited time and resources. So these are all about answering questions. You'll often notice a focus in the past on system metrics like CPU and memory, disk, et cetera, which are fantastic. However, there's a welcome trend over the last few years in tech towards application level instrumentation. So system metrics are great for these first two questions. What's slowing down or breaking, and did my change help performance or hurt it? Application level instrumentation, on the other hand, can be incredible for prioritizing work. Where are my efforts best spent, and what features may no longer be worth supporting? So really fun. We're just going to do some code. Don't worry about what it does, but this is a method that is called the most frequently of any method, function of any function in the PyPI code base. It's a search. So we're just going to instrument it. We're going to start finding out how it's operating, and we're going to do 2 lines of code. We're going to import a reporter, and we're going to time our function with a decorator and tag it with some tags for a reason you'll see later. Those 2 lines of code get us 5 wonderful metrics. Counts, average to call time, median call time, 95th percentile call time, and max call time. So the count looks like this. It's just raw count per bucket over time. You can treat that as a rate, which is sometimes helpful. And you also get the timing stats, which shows you, average is looking pretty good, median's up there, 95th percentile is not too bad, and max is, it's okay. But when we put these together, we start to actually get some real advantages out. This is basically multiplying the count times the average call time to understand how much time on average a specific RPC method is costing us in the back end. So we see this sort of blue line that's spiky. I believe that is a call for getting release URLs, which is just called so frequently. So if we can optimize that URL, we can reduce the number of active workers. If we can optimize that function, we can reduce the amount of active time on the back ends. So it's really good for prioritizing work and finding where we're going to get the biggest advantage. So here's a redux. We're going to do some timing around our calls to Elasticsearch. Start and end time, we could do this with a decorator or context manager, but we're going to just do it the old-fashioned way, where we set a start time, set an end time, and we emit a metric on the amount of time we spent calling Elasticsearch. Again, we get the same average, mean, 95th percentile max, and we can use this to determine if Elasticsearch, we need to go back in and consider changing the way indexes are handled or something, or determine when it's being problematic. The other thing we do is, since we're timing out the code, we're able to increment the counter or we'll increment a counter every time we time out, so we can actively inspect whether or not our timeouts are sane. So if our timeouts are too strict, most of the time when you search, you're going to get a blank result, and everybody's going to be mad. So it's important to keep track of those over time as well, to say, why did we have a sudden spike in timeouts and 300 people got empty search results? Speaking of metrics, catching your errors is a really good thing too. So we've been really lucky to have Sentry offer us basically all the Sentry service we can handle, and we spit out a lot of errors. So it's always super helpful, since we don't have good test coverage, to be able to go back and look at what actually is causing this new error that's coming around. And so being able to see your local and global variables and the state of the request has been really, really productive. So scaling with tactical updates, making changes to a pretty busy service that has almost no tests and many people rely on can be pretty problematic. And one of the biggest places where we've made probably the biggest change that's been made to the PyPI code base to try to make it more performant has been dealing with search. It's the most common method called, so it was kind of important. This is the search method. It's absolutely incomprehensible to read, but I'm just showing to you to get a relative size for what it's doing. Importantly, what it does is it spits out 1, 2, 3, 4, 5, 6 queries that do or SQL-like clauses against a table that is 130,000 long. Anyway, so you end up with a fire. Like, the servers are on fire. Every time somebody searches, it probably was great when there were a dozen or so packages, and probably slowly slowed down over time until we got where we are. So Elasticsearch, for search. So this change was really effective, and what was really sharp about it was we were able to go from, taking the same naive approach for search and move towards a similarly naive approach, just using Elasticsearch in equivalent amount of code. That change was really, really, really successful. We went from search taking well over a second to 2 seconds to about 250 milliseconds on average. And the advantages there is our number of 503 errors went from sort of constant to almost null. Caching. Caching HTTP is incredible. It's built into the protocol via the cache control headers. You have tons of options for how to do HTTP caching, and it's generally bolt-on for most easily cacheable things. So get a CDN and start using it can dramatically reduce the amount of backend resources you're using if it's necessary. Again, I'm going to say thank you so much to Fastly. It'd be literally impossible for PyPI to be available without them, at least over the past 5 years or so. More interestingly, caching internal stuff can be super helpful. If you've ever used Django, you know that Django has a pretty strong caching framework built in. Caching framework built in for caching your rendered pages and such. This is a snippet of Puppet source code. And on this line, Puppet calls a XML RPC request to PyPI to get the latest package releases. If you're familiar with Puppet, it's a server orchestration and configuration management library that are used by some huge companies. This is a valid PyPI XML RPC request. There are two problems with it. One is it's a post, and posts can be difficult and tricky and dangerous to cache. And secondly, since it's an XML, since the payload itself is XML, you won't necessarily have support in your HTTP caching layer to parse it so that you can cache the correct thing and give it back. So without being able to cache it effectively, when a large company rolls Puppet out or tries to spin up a brand new cluster, you can occasionally end up with a basically thundering herd against PyPI. So we were also able to implement internal caching for some of these methods using a decorator approach and some Redis. So thinking carefully and designing a relatively simple, least recently used cache was able to get us this is much worse than it used to be. I don't know why. I need to look into it. But blue is our hits and purple are our misses. So we're about like 50% effectiveness for this, but it can be really helpful. Rate limiting. If you're running a big enough service, you probably, or if you're involved in a big enough service, you probably are familiar with rate limiting. If you've ever written a script that's way too eager, you're probably familiar with rate limiting. And if you're more interested in rate limiting, I am going to limit time here, and you can read a post from Stripe. That's so small. Stripe.com/blog/rate-limiting. Really good stuff. They talk about a lot of good stuff. We're going to skip rate limiting though. Thank you. So in addition to rate limiting, ban listing specific clients can be really helpful occasionally for two reasons. One is it can quickly restore the effectiveness of your service if a single client or IP or something you can identify is really causing you trouble. Fastly supports this with edge dictionaries, which has been really helpful. I can throw out an IP address or a CIDR and quickly make it so all responses to them have an email address they can email to say, hey, we want to help you be successful, but we also need to push you off. And so we get to have a communication, understand how people are using the service, and also hopefully point them at a better solution for how they want to do that. And then a range of IPs as well. If you have a big honkin' old service, you should remove as many features because deleting code is fun. Security and error footprint are reduced. The scope for the software that's replacing what you're currently running is obviously limited at the same time, and it gives you some migration strategy around. As you remove code, you can shim in. You can shim in. I forget what that bullet point's about. Anyway, shout out to Alex Gaynor. He stole 28,201 lines of deletion from me recently. So anyway, simplifying architecture. This has also been super helpful. It's really easy to feel like you're running through a murder mystery mansion in an older code base. And sometimes really all you need is to step back and think about what the base concerns are. So maybe a more modest solution will suffice. Some ways we've handled this is moving file storage from a local disk out to S3. Live download counts have been deprecated in favor of Google BigQuery. Hosting our own Postgres, we no longer do that. Heroku offers us a place to run our database. And home-rolled StatsD and Graphite, removing that and going to Datadog. So to review, metrics, scaling with tactical updates rather than just trying to rewrite everything at once. Caching as much as you can, removing features and simplifying architecture. So last bit is about contributing. So this is the primary reason, like I said, I want to do this talk. But if you're interested in getting involved and helping out with PyPI and with packaging in general, use pypi.org. So pypi.python.org is the old code base. pypi.org is the new code base. So using it for browsing, using it as your index, using it for search, is really helpful because it helps us identify possible variances between the old and new code base. So if you see something, say something. That's what you say in New York, I guess. GitHub.com/PyPA/warehouse is the code base for the new effort. There's a large issue tracker, and we're pretty good about labeling things that are like optimized for a first-time contributor or for front end, back end, et cetera. So hopefully you'll be able to find something that is up your alley. There's good documentation on getting involved by setting up your development environment and setting up and shipping features at warehouse.readthedocs.io. In general, for packaging questions and problems, we have a meta tracker at github.com/pypa/packaging problems, where you can just discuss like this confused or bewildered me, or I'd like to see something new change. And finally, if you're lazy and you want to solve it with cache, donate.pypi.io is an effort of the Python packaging working group. So we're a working group that was basically put together to make PyPI and Python packaging sustainable. And we welcome your funds as donations to the PSF, earmarked for packaging, and that's tax deductible and everything. Thank you. My name is Ernest. You can find me there on Twitter. And if you have any questions, comments, feedback, et cetera, you can find me after the talk.